Okay, so this is number one. This is the numeric controller here, and then obviously the LED. So here we have the numeric control, and I have it routed to uh, a subtraction here. So what it does is it takes rounds to the nearest integer, so whatever number you put in, round to the nearest integer, and then I subtract that from the original input number, and then we check if that's equal to 0, and if it is, then the LED lights up. So if we were to run this, obviously 0 works. 1, 2, 3, etc. But if we were to enter something like 3.3, it doesn't light up. Something bigger, I don't know, 1098.7, not an integer, but 1098 is. So that's that. Number 1. Okay. Number 3 is next. So, alright, so this was the one we did in class, parallel resistors. Here you have your two input controls here, resistor 1 and R2. Then we take the reciprocal of each one, divide them, and then, or add them rather. We take the sum of each reciprocal, and then do a division, 1 over that sum. And then we have that output to this display right here. So, if I were to put in 2 for each of these, we'd have 1 over 2 plus 1 over 2, and then do 1 over that. So that would look like, say, this. Yep, and that gets 1. And that checks out, and then change either of these, say, put this at 6, 1.5, and because it's a sum, if the other one was 6 and this one was 2, it would do the same thing. Yep. So that's number 3. Number 4 is the sine function. This one is pretty simple. Just have numeric control here, input your angle in degrees, and then through this function it converts it to radians, and then that radian output is sent to the sine function, which then just tells what that number is equal to in sine, what the sine of that radian is. So if we were to put in 45, that should be 0.707. So 45 degrees, and that's correct. And I have it set to round to 4 decimals, just because I think it looks nicer. So even if I were to put 90, it should be 1, still just 1.000. And I just did that by going into the properties, but that's not super important. 180 should be negative, or 0 rather, and then 270 should be negative 1. Nope. 270. There we go. Yep. And 290 should be a little bit above negative 1, which it is. So that checks out. All right. 4, 6. Okay, so here we have an integer input, and then we do we divide it here by 2. And then we don't care about the quotient, so that doesn't go anywhere. But the remainder is output to here. We check if it's equal to 0. If it's not equal to 0, this sends a true signal here. And this is I forget what this is called. The select, yeah. So this is a select function. So what it does, if it gets a true signal, it takes this and outputs it to this string output. Or if it's false, it takes this one. So if we input, say, 2, we divide, the remainder would be 0. So it is true that it's equal to 0. So this would give us a false output here. It's not equal to 0. So yeah, even is the false, and then we'll go there. And 2 is an even number. So just to check that, let's see. Yep, 1 is odd, 2 is even, 3 is odd, 4 is even, and it continues. If you were to put a decimal or something that's not an integer, say, I don't know, 1.2, just have it round down through here to the nearest integer. So yeah. Okay. And 7. This one is just a coin flip. It's pretty simple. We have a random number generator here between 0 and 1. And then here, this is greater than or equal to. And so we're comparing if the number is greater than or equal to 0.5, then it sends a true signal to the select function, which sends out heads, which goes to here, and then here output tails. If it's false, meaning it's less than 0.5. So this one, there's no input or anything, it just runs. So we can have, okay, so that time we got tails, heads, tails, heads. And if you run it continuously, it just freaks out, which usually would make sense. And we can check, one thing I did just to make sure it was working was do a numeric indicator and then just wire that also to the random number generator, just to make sure that the number it's giving is actually greater than or equal to 0. So here we got 0.05, so that's less than 0.5, and it gives us tails, which is correct. Do it again, 0.02, 0.6, that's greater than 5, so it should give heads, and it does. So that's good. And then finally, number 8. Control E. Alright, cool. So this one is pretty simple. We just have A and B buttons wired up to an AND node here, and then it connects to this LED that lights up if this is true. So if A and B are both pressed, this should light up. And if one or neither of them is pressed, it shouldn't light up. So not lit, doesn't light up, but now if they're both pressed, it does. So that just tells if A and B are lit up, then that is. And that's that. Alright, yep, that's it.